So, part A of this question is to test the null hypothesis that alpha is equal to 0.1 using the pool t-test. So we need to identify our alternative and our null, and our degrees freedom is given and is 8. So, we start with, sorry about that. So we start with identifying our null and our hypothesis. So our null is our mean of the Persian cheetah weight minus the mean of the African cheetah weight is equal to 0. And our alternative is the mean of our Persian weight minus the mean of our African weight does not equal 0. Okay? So those are our null hypothesis and our alternative hypothesis. To test the hypothesis, we must do part B first. So to start part B, we need to find our t-value from the table. So we're given our degrees freedom, which is 8, and we're given our alpha, which is 0.1. So since this is a two-sided test, because that is our alternative is does not equal to 0, we have to divide our alpha by 2. So that is equal to 0.05. So we can get that value from the t-table, and that is 1.86. Then, to find the T statistic, we use this formula, and that is equal to the mean of the Persian weight minus the mean of the alpha weight minus our alternative hypothesis, which is, our null hypothesis, which is 0, over our standard error for the mean difference. So first we must find P bar and A bar. P bar is equal to the sum from I equal to 1 to 5 of xi minus, or sum xi, sorry. And that's going to be over the number of data points we're given, which is 5. So that ends up being 279 over 5, which is also 55.8. Then we must find our A bar, which is the sum of A over 5, and that is equal to 259 over 5, which is 51.8. So we have those two values. Our next value to find is the standard error. So our standard error pooled is equal to our standard deviation pool, if I can write, standard deviation pool, times root 1 over n plus 1 over n. So n is the number of trials for the Persian cheetah, and m is the number of trials for the African cheetah. And those are both equal to 5. So n is equal to 5 and m is equal to 5. So now that we have that equation, we still don't know our standard deviation pool, so we must find that. And we use the formula of, so it's going to be n minus 1 times the standard deviation of the Persian cheetah squared plus m minus 1 times the standard deviation of the African cheetah squared. And that's going to be divided by our number of trials for the Persian plus our number of trials for the African minus 2. So we have two unknowns in this. We need to find our standard deviation for our Persian cheetah and our standard deviation for our African cheetah. So our standard deviation for our Persian cheetah, that's equal to the sum of xi minus x bar squared over n minus 1. And remember, n is the number of trials for the Persian cheetah. So that equals to 51 minus 55.8 squared plus 55 minus 55.8 squared plus 52 minus 55.8 squared plus 48 minus 55.8 plus 54 minus 55.8 squared. And that's all going to be divided by 5 minus 1, which is 4. And that is equal to 6.2. So then we must find our standard deviation for the African cheetah squared. So that's equal to the sum of ai minus a bar squared over m minus 1. And remember, m is the number of trials for the African cheetah. So that is equal to, I apologize, I messed up here. This is a 54 up here. And this is supposed to be a 60. And this is supposed to be a 56. And that is 40. This is supposed to be a. This is supposed to be a. $55. And that is supposed to be 54. So let's go back to our standard deviation squared for our African cheetah. So that is 51 minus 51.8 squared plus 55 minus 51.8 squared plus 52 minus 51.8 squared plus 48 minus 51.8 squared plus 53 minus 51.8 squared. All of that is going to be divided by 4, because m minus 1, which is 5 minus 1, is equal to 4. And that is equal to 6.7. So now we can calculate our standard error pooled. So our standard error pooled is equal to the root. So we have n minus 1, which is 4, times our standard deviation squared of the Persian cat, which is 6.2, plus our m minus 1, which is 4, plus our standard deviation for the African cat, which is 6.7. All that is divided by is n plus m minus 2, which is 8. And that standard error pooled is 2.5397. Okay, so now that we have our standard error pooled, we can now calculate the bottom and the top of the T statistic. So first I'm going to calculate the bottom. So the bottom is standard error pooled times the root of 1 over n plus 1 over m. And that is equal to 2.5397 times the root of 1 over 5 plus 1 over 5. That's equal to, again, 2.5397 times root 2 over 5. And that is equal to approximately 1.606. So, after we get that, we know that's our bottom. We need to calculate the top. So our top is, it's going to be P bar minus A bar minus the hypothesized difference of the means, which is 0. And that is equal to 55.8 minus 51.8 minus 0, which is equal to 4. So our T statistic is equal to 4 over 1.606, which is equal to 2.49. So now we found our T statistic, we can now test our hypothesis. And our hypothesis, so our T star is equal to 1.86. Since our T value we found is equal to 2.49, which is larger than 1.86, we reject our null. So now we do part C. Part C, ooh, that was bad. Part C is just calculating the 95% confidence interval, or 90% confidence interval. But we are doing a two-sided confidence interval, so our formula we use is, Our formula we use is our P bar minus our A bar plus or minus our T star score that we found from the chart times our standard error pool. We have all these values already, so this is 55.8 minus 51.8 plus or minus 1.86 times 1.606. So I got, actually we're going to round up that 1.606 to 1.61 just to make calculating it a little easier. So our confidence interval is, sorry about that. Erase that real quick. So our confidence interval is 4, I don't know why this keeps happening. 4 plus or minus 2.9946. This gives us a confidence interval from 1.0054 to 6.9946. And that is how you do question 1 of exam 1 of spring 2019.